Hello and welcome to another one of D's ADD videos. Today we're going to continue discussing the concept of electron configurations by looking at the example of platinum. Platinum is an exception to the exception. So let's look at the exceptions handout. This is available on dallaseducation.org. One asterisk means that it did not follow the normal borrow rule, meaning it's going to borrow electrons from the S subshell to make the D more stable by making it half full or completely full. Then we look at the exceptions to just Aufbau in general, in which they don't follow the trend that you should be used to now in your filling of these orbitals. Okay, so if they don't fill according to this diagonalization trend, then they've got 2 stars by them. So let's look at platinum here. Platinum says that if we're looking at the periodic table, here we're 2 away from being full, right? So you would expect it to be, if we're following the rules, sorry, wrong one. It should be just like this one. Let's do a different color. Let's do the yellow we were using. So it's on the 6th row, is it? Yes. So on the 6th row, we're going to have the 6s2. Then we should have let's look at the order we fill in. Okay, so 6s2 then becomes, so we're right here. So we should go to 4f, then 5d. Okay, so the periodic table tells us the same thing. We go to 4f first, and then 5d. And you'll see some situations on that table in which instead of going to 4f, they'll just fill the lower energy D orbital up a little bit and ignore the F. So there are some exceptions. I don't think they'd give you too many of them. As long as you know the main ones, you should be okay. Definitely know the borrowing rule. So you see how chromium and copper are borrowing 1 electron and 2 electrons to make the D orbital half full or completely full. Actually, both of these are borrowing 1 electron, sorry. And then back to platinum here, we can see that it has 6s1, 4f15, and 5d9. Let's see how that works. So if you were using the normal borrow rule, you'd first take the noble gas on the period before the 6th is xenon. See that right there? There's your platinum. And you would write xenon. And then we would have 6s2. And then when we go to the F, remember we subtract 2 from the principal quantum number. So it's 4f. And we completely fill those up. And then we go to the 5d. And what it should be is 8. That's the normal basic thing. And what I've told you is you can borrow electrons to go from, to make this completely full. Well, the problem is, this one, what happens is you get, let me go ahead and write the answer. This is the exception to the exception, because it doesn't borrow 2 electrons, it just borrows 1 and makes this a 9, getting it closer to being full, okay, but not completely full. So if we look here at the periodic table, the reason it does that is if it borrowed both the electrons, the electron configuration would be what? 4F14 5D10 with the xenon in front. So let me show you what I mean by the exception to the exception. Here we're looking at the electron configuration of palladium. You see how palladium borrowed 2 electrons? Let's go ahead and look at the electron configuration. So you see how palladium should have had 2 electrons in the 5s orbital, but it borrowed 2 of them to become completely full in the d orbital. All right. So when we're looking at the electron configuration of palladium, it's just a 4d10 and the noble gas of krypton before it. Okay. This is just showing you the valence shell there. Whereas platinum doesn't exhibit that same behavior. Platinum only borrows 1 electron from the 6th s subshell and gives you a 9. Okay. Here you can see how gold borrowed 1 electron from that same, but became completely full. So you would expect platinum to behave like palladium, in which it borrows 2 to get all the way up to here completely full, but it does not. All right, so I just want to point that out. Make sure you know the exceptions to the exceptions, like platinum here for the borrowing rule. These over here in the period, 5th period, niobium, ruthenium, and rhodium. Okay, and then the rest of these double asterisks, what they do is they don't follow the trend of electron configuration filling. They fill, for instance, what will happen at these higher energy levels is that instead of filling the F, what will happen is it'll start filling the D's. If there's only a few electrons to go around once we get to this point, it'll start filling the lower energy level a little bit. It might give 1 to the F, but it'll go to D first. So normally it should have been 5F, 6D, then 7P after 7S. But you can see that after some of these, let's see. So here, look at thorium for instance. We have 7S2 and then 6D2. So if we're looking here, after 7S2, we should have 5F, but we went to 6D. So that's messing with the off-bow principle. Okay. All right, so that's enough of that one. Let's go back to our last 2 problems. This is actually getting to be a longer video than I expected, so what I'm going to do is, for all my attention deficit disorder people, stop the video here and start a new one for the 2 cations. Okay, so make sure you watch part 2 of the more advanced electron configurations. Practice, practice, practice is the most important part. Thank you and have a nice day.